Hey everyone, it's me, Miss B, and in today's video we are looking at the Unit 2 Lesson 5 practice problems for Illustrative Math Algebra 1. So let's start with the first one here. We are going to select all the points that are on the graph of the equation 4y minus 6x equals 12. Now there are a couple ways we can do this, but we're going to explain or show work for each letter to support our choice. Now, if it's on the graph, that means it's on the line, and that would mean it is a solution, which means we can plug these numbers in for x and for y. So each of these is going to have x on the left and y on the right, meaning we can plug them in to check and show our work. So that's the way I'm going to do this because they didn't ask us to use any sort of graphing technology. So I'm going to avoid using a graph here and just actually show the arithmetic. So since it is 4y minus 6x, we would do 4 times negative 3 minus 6 times negative 4. And we want this to be equal to 12. So we're going to simplify it and see if it works. So this would give us negative 12 and then plus 24. So we get a negative because we have a positive times a negative here, but this negative 6 times the negative 4 makes a positive 24. And negative 12 plus 24 is equal to 12. So A is one of our answers. And I'm going to alternate using red and blue just so you can see which work goes with which problem. That way they don't blend in as much together. So for B, we're going to do the same thing. We're going to say 4, but it's 4 times y, so that's the 1.5. And then minus 6 times negative 1. And we want to know, is that going to be equal to 12? So 4 times 1.5 is going to be 6. And then negative 6 times negative 1 makes positive 6. So 6 plus 6. And yes, that equals 12. So we're good. And that means that B is also one of our answers. Next, we're going to check C. So this would be 4 times negative 2. And then minus 6 times 0. And we want to know, is that equal to 12? So 4 times negative 2 is going to be negative 8. And then negative 6 times 0 is 0. This is not equal to 12, so it is not one of our answers. And we're going to do the same thing. So 4 times 3 minus 6 times 0, is that equal to 12? 4 times 3 is 12, and then this is plus 0. Yes, that equals 12. So D also is one of our answers. And we're going to keep going. So 4 times negative 4 minus 6 times 3. Since they asked me to explain or show work for each one, I'm just going to show work for all of these, and then we'll use that to determine whether it's yes or no. And we want to know, is this one equal to 12? So this makes negative 16, and negative 3 times positive, or I'm sorry, negative 6 times positive 3 would give us negative 18. That is not going to be equal to 12. It's going to be definitely a negative number, and we wanted a positive 12. So E is not one of our options. Last one to check here is F. So this is 4 times the 4 minus 6 times the 6, and we want to know if that's 12. This is 16, not 8. 8 would be if I added them together. 4 times 4 is 16, and minus, because we have negative here, 6 times 6 is 36. That is not equal to 12 either, so F is not an option. Okay, so that's all for question 1. It is A, B, and D are our answers. Hopefully doing the alternating colors helps you see which work goes with which question. If you need to write yours out for your teacher so they can see it a little bit better, maybe write it out a little more horizontal. I'm sure they'll be able to identify what work goes where. Question 2, we have a graph of an equation. That equation is x plus 3y is equal to 6. We want to select all coordinate pairs that represent a solution. So we have a couple different ways we can do this. Because we have a graph, we can actually find our coordinate pairs because they are x comma y. Oh, sorry about that. I don't know why it went a little crazy on me. X comma y. We can find these on our coordinate plane and then identify which ones actually land on our graph. Or we could use the plug-in method that we used on the previous question and just use the formula. I'm going to use the version that uses the graph just to show you a different way to do it, but the plugging in and checking to see if it's equal way also works. So for this first one, 0, 2, that means along the x-axis. I am using 0 on the x-axis, so I'm not moving left to right, but then I'm going up to 2 on the y-axis. So that's right here. So I'm going to label this point. I think red stands out a little bit better on here, so I'm going to use red. And yes, that lands on our line. So A is one of our options, and I'm even going to label this A. That way you can see where it's at. Now, if we did 0, 6, still 0 left to right, but then on our graph, we would go all the way up to 6 on the y-axis. This is B. Not going to work. C is 2, 6, so we would go 2 spaces right, and then 1, 2, 3, 4, 5, 6. Still not going to work, but I'll still put my point here and label this C. C doesn't work. D is 3, 1, so if we start at 0, 0, we go 1, 2, 3 to the right, and 1 up. That does land on the line, so I'm going to mark this here and put D. D is going to get circled because it is the answer, or it's one of them. And then we're just going to check the last two, 4, 1, and 6, 2. So if we went over 4 spaces and up 1, this right here is close to the line, but not on it. So E is not one of our answers. And then let's check 6, 2. That's going 6 spaces, 1, 2, 3, 4, 5, 6, and up 1, 2. Definitely not on my graph either. So this was F. And those only two that actually land on my graph are A and D. So A and D are my only answers to this question. That's it for the front page. Let's flip to the next side, and we'll look at question 3 here. So a theater is selling tickets to a play. Adult tickets cost $8 each, and children tickets cost $5 each. And they collect $275 after selling X number of adult tickets and Y number of children's tickets. So that's our background information here. You can see they have children's tickets on the y-axis, adults' tickets on the x-axis, and then this graph is representing their equation. They want to know, what does this point, 30, 7, mean in this situation? Well, since it's on the line, we know it's a solution, and we're just going to tell them what the numbers mean. So 30 is on our X, that's adult tickets. So we're going to say it means they sold 30 adult tickets and the y-axis one was 7, and that's children's tickets, so and they sold 7 children tickets. They didn't sell the actual children. And 7, we'll say child tickets. They're definitely selling tickets, not people. So it means they sold 30 adult tickets and 7 child tickets. And that's it for this question. They just wanted you to interpret what that point meant. So we didn't actually have to create a graph. We didn't have to create an equation out of any of this. It was just, what does it mean? So for this next question, it does say technology required. So I am going to switch back and forth between here and between my Desmos graphing calculator. So Priya is starting with $50 in her bank account, and then she is depositing $20 each week for 12 weeks. Now, they want us to write an equation that represents the relationship between the dollar amount in her bank and the number of weeks that she's saving. Well, between my inputs and outputs, I believe time is almost always our input, and in this case it will be. So her number of weeks that she's saving, I'm going to use that as my input, and that's going to be on my horizontal axis or my x-axis. Because they're telling us to write an equation in between these two, that means they're going to be the two different variables. So if they say the relationship between, and then the dollar amount and the number of weeks saving, that means one of these is going to be input, one's going to be output. So I'm going to say dollar amount is the output and number of weeks saving is my input. So that means input would be normally x-axis and output would be y. Now I'm going to create an equation here that doesn't use x and y, but when I actually plug these into Desmos, it sometimes is a little picky and it may not actually allow me to enter it using the variables I'm going to use. So I'm going to say that this equation here, her dollar amount, I'm going to say D equals dollar amount. And then I'm going to say that W equals weeks. It's just the number of weeks. Her dollar amount that she's able to save is equal to the amount of money she starts with plus, because she's adding an amount, she's depositing, that means she's putting money into her bank, $20 for each week that she's saving. So for Desmos, Desmos is going to require me to write this in a little differently. So my Desmos version, I'm going to need to say y equals 50 plus 20x, because weeks is my input, which is x. So, right, D was my output. So when I enter it in Desmos, you'll see me enter it this way. Okay, so now we're supposed to graph our equation using the graphing technology and then mark the point on the graph that represents the amount after 3 weeks. So I may do a little screen capture of this or something like that, but I'm going to then just acknowledge that point. So let's move to Desmos graphing calculator and graph that equation. So I'm going to use the y equals version, not the d and w, because it's not always a fan of me when I use different variables. Unless you put something in function notation, it tends not to like it. So if you just enter those numbers, you get this kind of graph, and it's like, oh, great, I can't really see anything. Now, I film these videos on my tablet, so it is touchscreen. If you're not using something that's touchscreen, you can use the little wrench tool over here, and then you'll see that it says x-axis and y-axis, and you can change those numbers. But that's a manual way to do it, and I don't really like that. Most of my students have Chromebooks that are touchscreen, so if you have a touchscreen Chromebook, what you can do is pinch on the axis you are trying to shrink or grow. So I'm pinching my fingers on top of my vertical axis here in order to shrink this down. And now I can see a little bit more information, and they wanted this on 3 weeks. You can also like spread it to expand. I'm going to expand until I can see 1, 2, 3, 4, 5, and 6. Okay. And I could make a table version out of this. I'm also just going to select it here. And then if you Yeah, so if you put your finger along the graph or your mouse, which might be easier, I'm using my Apple Pencil here, you can find ordered pairs. Now this one's being a little finicky with me, but it is 3, 110. That's because my input is weeks, and then my output value would be how much she has saved. So what I am going to do is you can actually put 3, I believe, and then 110 as a point there, and I can label it so that it shows. So this is what I'm going to snap a little picture of and put on my homework. Instead of sketching a graph, I'm going to actually save that as a photo. So if I go back here, I can then take this photo, I'm going to crop it down and just show maybe some of the relevant stuff here. That seems good. We're going to save it to my photos. And then I can actually add a photo in here, and I see it up at the top. And I can actually make this a little smaller to fit. So we're going to mark that point and show my graph. So she will have $110 after 3 weeks. Now, they're also going to ask us how much does it take her to have 250 and mark that on the graph. So I'm going to switch back to my graph here, and I am going to find, now in order to find 250, that is an output value. So I might have to zoom out a little bit here because it's not quite shown on my graph. Now what I can do is I can say, well, I know this is an output value, so I can say y is equal to 250 instead of finding it. And this will give me a horizontal line that I can use to actually just click on both of them, and it'll give me a point here with the intersection. So 10 and 250. So I am going to show, and it says mark this point on your graph. I'm just going to take a screen capture of that, crop it down to the relevant pieces, and oops, zoom out a little bit here. This looks good for my relevant stuff, maybe there. Okay, and so that's going to be what I'm saving here, and I will put this picture. It says to mark it on the graph, so I'm just showing you that I'm marking it on my graph, I guess, by including my photo here. That is at 10, so it is 10 weeks. If you don't want to actually graph this, I would still just say sketch a version of it and label the point, but still practice using Desmos to find those pieces. Then that's it for question 4. We only have 2 more questions. So we have questions 5 and question 6 on the back page here. Now the table shows the amount of money A in a savings account after M number of months. So we want to select all equations that are representative of the relationship between the amount of months and the amount of money. So we have a couple things. We have 5 and 1200, 6 and 1300. I am seeing that these are going up by 1, and it looks like these are going up by 100 as we go, and we can check that pattern. Yeah, it looks like we're increasing 100 every time we go up 1. Now, it's not quite 100 times this number because this is 1200. So A really says 100 times that number is the answer. So it's not going to be this. Now, if it's month minus 5, that would actually give us 0 at 5 months. That's not really going to work. We want to know, how do we make this number into 12? So 12 minus 5 is 11. 10, 9, 8, 7. So 7. So we want to do our months, but then maybe add 7, or just have started with $700. So months minus 5, not going to work. If we subtracted the 7 from the total, then it would be 100 per month, and that's what C shows, but not if we're subtracting the 1200. It also works if it's added to both sides, because that's the same as C, where we just add the 700 back to both sides and we get this. And it's not our 1200, and 1200 plus 100 times m minus 5. This one at the bottom actually works as well if you multiplied it out. So it says show your work or explain your choices. I explained it verbally. You can show it differently. We're just going to write this one out real fast because I don't know if you can hear the bell in the background, but my class is about to come in soon. So C of 5 equals 450. Well, C is cost and N is the number of apples. So that's going to be the input. So we're going to say this one means the cost of 5 apples is $4.50. And if it just says C of 2, that just represents the cost of 2 apples. They're just not telling us how much money that is. So this is the cost of 2 apples. And that is it, because there are only 6 questions on this assignment. So my students are all waiting to come in. So thank you for being patient. They are waiting on me. So this has been Illustrative Math, Algebra 1, Unit 2, Lesson 5.